Pretty interesting publication here. Forever Connected, the lifelong biological consequences of fetomaternal and maternofetal microchimerism. It's basically a review of research looking at fetal cells that enter the mom's body and maternal cells that enter the fetus's body and then stay there for years or decades, and what exactly those cells are doing. If you just want the bottom line, the authors conclude that the intricate interchange of genetically foreign cells creates a lifelong bond between a mother and her child that contributes to the survival of both individuals. In other words, they're helping each other out. They talk about how they've been able to find fetal cells in practically every organ in mothers, and they've also found maternal cells in many fetal organs. What these cells are doing isn't totally clear. For a long time, researchers thought that the cells were causing an immune response, similar to if you have someone who needs an organ donation, but then when they get the donated organ, their body rejects it as foreign. They've seen correlations between higher concentrations of foreign cells in the mom or in the child and certain diseases. But the thing is, they don't know if it's because the cells are causing or participating in the disease, or because the cells are proliferating to try to fight the disease or to aid in tissue repair. Increasingly, they're thinking it's more the second thing. For example, this study found a lot of fetal cells in the scar tissue from cesarean sections. Obviously, this is after the child is born, and they think that the fetal cells migrated to the damaged site to help repair. Research has suggested that fetal cells in maternal tissues and organs are working as stem cells or progenitor cells, which means that they can differentiate into different types of body cells depending on what the body needs. There have been quite a few studies on this involving mice, where the fetal mouse cells will go into the mom's body and help repair heart tissue. But the exchange of cells is a two-way street, with maternal cells also going into the fetus. And again, they're not totally sure of the role of maternal cells in fetal body systems, but given there's already a lot of research showing purposeful transfer of protective maternal antibodies, they think that it would not be surprising if this transfer of other maternal cells serves to help develop neonatal immune systems. Maternal cells in fetal body systems may even help with future generations. There's already research to show that when a woman is Rh negative, if her mother was Rh positive, she will have less strong of an immune response to an Rh positive baby. In other words, the exchange of cells between mom and daughter may affect the daughter's immune responses when she has children, and this could apply not just to the Rh antigen, but to a lot of different kinds of cells. Obviously, nature is filled with imperfections, but it would make sense from an evolutionary standpoint if it turns out that the exchange of genetic material between mom and child helped to protect and strengthen both of them.